Okay, we're going to keep studying oxygen-containing organic compounds. And those two types of compounds we're going to study today are called aldehydes and ketones. Okay, aldehydes and ketones. And the same, like we're doing in chapter 3, when oxygen is involved in bonding in organic chemistry, oxygen contains two bonds. Okay, in a neutral organic compound, contains two bonds. And those two bonds could be two single bonds, like we studied in chapter 3, in alcohol, in ether. Okay, those compounds, oxygen, are single bonded with either an oxygen and a carbon, or two carbons, like in ether. In this chapter, we're going to see compounds with a double bond on oxygen. Okay, now of course, a double bond on oxygen is the double bonded to what? To a carbon. Okay, we know the organic molecules are built on carbon. We have seen both types of organic compounds with CO double bond in chapter 3 already, when we study the oxidation of alcohols. Okay, if you guys remember, and we're going to see those reactions in your quiz as well today. When an alcohol is oxidized, we know we're reducing the amount of CH bond. We're taking the hydrogens away from the O and what? And the C. Okay, and the C. Now, the reaction of oxidation is the same, but based on what type of alcohol you're oxidizing, you may end with two types of product. Okay, if you start with a primary alcohol, in which the C has two hydrogens, if that's the case, after oxidation, this carbon will still have a hydrogen what? Remaining, right? Primary have two hydrogens. You remove a hydrogen during oxidation. So after oxidation, you still have a hydrogen remaining. So that means in the product, the CO double bond carbon still has a hydrogen on it. We call the resulting compound an aldehyde. Okay, an aldehyde. If you start with a secondary alcohol, that means on this carbon, there is only one hydrogen. So during oxidation, this hydrogen will be what? Will be removed. So your product, the CO double bond carbon, will have what? No hydrogen in it. You have two groups. Why we have two groups? Because secondary alcohol has what? Has two groups. Your product has two groups. Plus a CO double bond. This carbon has four bonds. So if that's the case, the product is called a ketone. Okay, that's what we're studying this chapter. Okay, it's chapter. So now it's easier on this slide. So first, what is the group? The CO double bond, the group is called a carbonyl group. Okay, carbonyl group. When you have at least one hydrogen on the carbonyl group, we call the product, or we call the function group a what? An aldehyde. If you have no hydrogen, means two carbons on the carbonyl group, we call the function group a what? A ketone. Okay, a ketone. Sometimes an aldehyde group, COH, is abbreviated as this, CHO. You know the H, the O means what? The H is single bonded with carbon, the O is what? Double bonded with carbon. That's how we write aldehyde group, CHO, if you want to abbreviate. Not OH. OH is what? Is alcohol. CHO means this O is what? Double bonded with carbon. Okay, that's sometimes we abbreviate and make it easier without showing the structure. So that's the definition and how each type of compound the functional group looks like. Okay, next. We know you guys know the structure now. First, let's take a look. Naming. But before you naming, I want to point out to you, and you may notice the difference because of the difference in their structure. In naming, there is some slight difference as well. Okay, if you look at these two compounds. The top one is what? An aldehyde. The bottom one is what? Is a ketone. The biggest difference is in aldehyde, because you need a hydrogen attached to the carbon. right? So this carbon has to be where? Terminal. Does it make sense? Otherwise, think about it. If it is not terminal, then there must be a what? A carbon here. If there's a carbon here, then this guy would no longer be a what? An aldehyde. Does it make sense? So if by definition an aldehyde needs a hydrogen and the carbon, that means this carbon is always what? Number 1. Okay, because it is at the end. Ketones are different. The ketone carbon, because there are 2 carbons bonded to it, so the ketone carbon can be anywhere. Internal the chain, in the internal of the chain, but not at the end. That's the biggest difference between the structure. And because of that, when it comes to naming, you will see that they're different. Okay, very quickly, guys. Take a look at these 8 structures. Can you guys tell me, out of these 8 structures, how many aldehydes or how many ketones are there? They're all carbonyl compounds. I'll ask one of you to give you 1 minute to take a quick look and mark it. I'll ask one of you to tell me how many aldehydes are there. I mean, the other ones will be ketones. Very easy. Okay, it's not a challenging question. Isabella?
Number 2, or like the second one on the first row, and then the next one after that. I think that's the only one. The only
That's all? Do you guys agree?
Yeah.
You guys agree? Yes. Okay, the second and third one, the first row, are aldehydes, and the rest of them are ketones. Okay, ketones. Okay, very good. Okay, these are, when you look at the structure, now you can at least what, recognize, right? When you this is the purpose of studying this class. Okay, we don't study complex molecule, but at least when you look at them, now you know what they are. Okay, what type of molecule we're dealing with, and what properties it may have after you study the class. Yes?
I'm sorry, which ones did you say that were?
The second and third one in the first row.
The second, third, yeah.
In the first row are aldehydes. Because of what? Because they have hydrogen on the carbonyl group. Okay, next, naming. Okay, naming. Because the carbonyl group for aldehyde is always on the terminal, we don't number that carbon when we name aldehydes. Because the carbon is always what? Number 1. Okay, when you number the chain, you number this one as number 1. And because it's always number 1, you won't see a number in front of the last word of the name, last name. That's the first important. Number 2 is the same. You find the longest chain containing this carbon. Okay, no matter what chain you're using, your chain must include this carbon. And then the name of the aldehyde is by changing the E of alkane into Al. Okay, changing the E of alkane into Al. And the rest of it is the same as we name other molecules. Okay, for example, this aldehyde, 4 carbons. The name of the alkane is what? Butane. Changing the E of butane into Al, it becomes butanol. Okay, butanol. And there's a bromo on number 1, 2, 3. So 3 bromo butanol. And you don't need to tell people where this carbon is, because this carbon is what? 1. There's no confusion, so we don't put a number there. Okay, put a number here. Okay, 3 bromo butanol. This one, again, you need to start with this number. This is number 1 carbon. When you find the longest chain, always include that carbon. 1, 2, 3, 4. 1, 2, 3, 4. Same, longest chain is 4, so butanol. And there is an ethyl group on number 2 carbon, so 2-ethyl butanol. Make sense? Next, when an aldehyde group Okay, when the aldehyde group is attached to a benzene ring, we get a new parent name. Okay, you guys know what parent name is, right? When we study chapter 2, phenol, toluene, aniline, and what? Benzoic acid. Now here, if an aldehyde group attached to a benzene ring, we have a new parent name. This whole thing, 7 carbons, is called benzaldehyde. Okay, benzaldehyde. So if your other groups on this parent name, you would name after what? Benzaldehyde. Okay, this 7 carbons all together is named a benzaldehyde. Then you name the rest of the groups. For example, in this molecule, this is benzaldehyde. And beside that, there is a chlorine on number 3. There is a methyl on number 5. Why we call chlorine number 3? Because chlorine start with C, methyl start with what? M. So I named this as 3, that's 5. So 3 chloral, 5 methyl, benzaldehyde. Okay, and we know if there's a parent name, this carbon is always number 1 in the rank. Okay, 3 chloral, 5 methyl benzaldehyde. Good? Easy, right? So after you get used to the system, the naming will be just some minor modifications. I think it depends. I think, is that today or next week? I forgot. Afternoon on your syllabus, I'll double check. We have a naming workshop. We're going to summarize all the namings we studied so far, and then do some practice so you get a whole picture about naming. Okay? Maybe today, I forgot. Okay, let's keep going. We'll check after that. Okay, now, when you name ketone, okay, name ketone, the biggest difference, okay, not the name is different, of course. The biggest difference is because the carbon of the carbonyl group, now it's what? Internal. And because it's internal, it can be anywhere. Internal of the chain, as long as it's not on the end. And because of that, when you name a ketone, you must tell people where this carbon is. Okay, where this carbon is. That means there must be a number in front of the name for the ketone. And the rest of it, it's still similar. When you find the longest chain must include what? This carbon. Now you number the longest chain from either end. This carbon must get the lowest number. So here, this is the carbon. It close to this end, so I number from where? Here, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4. Where is this carbon? 2. And the chain is pentane. For ketone, I drop the E of pentane. Add O-N-E. Okay, drop the E of pentane. Here, everything is here. Add O-N-E. See that? Drop the E. Add what? O-N-E. So pentane becomes what? Pentanol. Okay, pentane becomes pentanol. And where is this carbon again? 2. So the name of this chain is 2-pentanol. Okay, that 2 tells people where this carbon is. 2-pentanol. And besides that, okay, again, after you put 2-pentanol, these carbons are done. And that O is done too because you named the pentanol already. So the only thing that's not named yet is what? The bromo. Where's the bromo? 1, 2, 3, 4. So 4-bromo, 2-pentanol. Make sense, guys? 4-bromo, 2-pentanol. If something you want to repeat or even write it down, I can do that. But I think you guys can write on your notes. 4-bromo, 2-pentanol. Of course, between number and letters, there's a dash. Okay, 4-bromo, 2-pentanol.
Thank you.
Good?
Yes.
Make sense, the name? That's the biggest difference. For a ketone, there must be a number in front of the last word, the name of the ketone. So, give you half a minute, 1 minute, I'll ask one of you guys to tell me the name of this guy. If you don't have it on your notes, you can draw it and then name it. Riley? Yeah, 2-pentanol. And what else? The name is 2-pentanol.
Ethyl's on 3, so 3-ethyl. And then the 2-pentanol.
Say it again. Whole thing.
It's a lot of words. Okay. 2-ethyl.
Well, you just said
Or
what?
3.
3-ethyl.
3-ethyl. And then 2-pentanol.
2-pentanol. Very good. See? I'm not judging your pronunciation. I may not pronounce the best.
Can you write that one out? What?
Okay, the molecule on the right. Okay,
Thank you.
on the right, just put on the board. Okay, it's 3-methyl 2-pentanol.
Thank you.
Okay, 3-methyl 2-pentanol. Make sense, guys? Okay, 3-methyl 2-pentanol. Again, between letters and numbers, there's a dash. Okay, there's a dash. Good? Last one. Okay, last one. And also easy. Okay. We know ketones, we have to number the carbon. But there's one exception when ketone is part of the ring. Okay, like this carbon, you can see that this is the carbonyl carbon is what? Is part of the ring. And if that's the case, we know this carbon is what?
Number 1.
Number 1. If that's the case, we don't number it. Because that's definitely number 1. So if the carbonyl carbon is part of the ring, you just name the cycloalkane and drop the E with what? And replace with what? O and E. So this is cyclohexane, then becomes what? Cyclohexanol. Okay, cyclohexanol. And again, because this carbon is 1, you don't name it, you don't see a number here, right? You see that? There's no number here because that's 1. If that's number 1, this is what? 3. And there's ethyl group on it, so 3-ethyl cyclohexanol. Okay, see that? Now you get an idea. When there's a possibility of different locations, you have to number. When there's no other possibility of a different location, you don't have to number it. Okay, cyclohexanol or cycloalkane with a carbonyl group, you don't have to number the ketone carbon. Good? Again, the biggest difference between aldehyde and ketone, not the name. The name is Al or O-N-E. Is what? Aldehyde, you don't need to number the carbonyl carbon. Remember, carbonyl carbon is the functional group. But for ketone, you have to what? You have to ask you, do I need a number? Most times you do. Most cases you do need a number for ketone. Except what? Cyclone. Okay, that's all for naming aldehyde and ketones. I'll give you a couple minutes. Take a look at the names. These are easier ones. Okay, these are easier ones. The top name is the IUPAC name. The bottom name is the common name. Okay, you don't need to worry about the common name, but if you remember it or somewhere you understand it, you can use it in our naming. It counts as correct. Okay. Unless the question asks you to name it using IUPAC name. Otherwise, you can use either. But again, what we're talking about is the top name. Give you some time. Take a look at the name if those make sense. The one in parentheses are common names. If it doesn't make sense, feel free to ask me, I'll explain. By now, naming should have been easy test, right?
Yeah.
The only thing is your quiz and test, I want you to be careful. Okay? Don't make like careless mistakes. Okay? I know most of you by now naming should be an easy task. The only thing is make a summary. And we will do that in our workshop. But you can make a summary about some most important rules for each type of compound, and then of course again practice. Good. Okay, again, you guys see that? Aldehyde, there's no number in front of the name, right? These numbers are for the groups. Of course, you need a number. But ketone, you do have a what? Number telling people where is that carbonyl. Carbon. Okay, carbon. All right, let's move on. Very quickly, a few aldehyde and ketones that are extremely common and used, and I want to show you a few in structure and also their uses before we move on to physical properties. Okay, the first one is this guy, the simplest aldehyde. Okay, aldehyde, only one carbon. Okay, one carbon. That means there are two hydrogens on the carbon. Okay, the simplest aldehyde. This is a aldehyde called formaldehyde. Okay, formaldehyde. And it's common name. Formaldehyde is common name. If you want to use the IUPAC name, it's a methanol. Okay, but this is a common name. And it's a gas. Okay, it's a toxic gas. Okay, toxic gas. And some newer built furnitures or paint may contain formaldehyde gas. We'll keep releasing formaldehyde gas. So that means if you buy new furniture in a new house, everything is new. Sometimes you need to open the window for a few days before really moving in because of the high concentration of formaldehyde. And 30% of formaldehyde solution is like this. Okay, like a little light yellow solution, smells really strong. It's called a formalin. It's used to an embalming fluid. Okay, fluid. If you're in the medical field, you will see those a lot. Okay, and next is a ketone. Okay, the simplest ketone. Okay, remember ketone need what? 2 carbons on the CO double bond. So at least you need 3 carbons for the simplest ketone. Okay, this is the simplest ketone. The IUPAC name is called the propanol. Okay, 2-propanol. But we use the common name of this ketone a lot more than the IUPAC name, and the name is called acetone. Okay, acetone. We will use the lot acetone in our lab as well because acetone is a very, very good organic solvent. Okay, the reason we use that a lot because the acetone not only dissolves organic compounds but also dissolves in water. Okay, so kind of like a media between organic solvents and water. And especially sometimes you wash glassware with water, acetone can rinse the water away so it dries faster. Okay, and because it's such a good organic solvent, it is one of the main components in nail polish remover. Sometimes they just use pure acetone as a nail polish remover in cosmetic stores or something. Okay. Next is a few aldehyde and ketones that are fragrant. Okay, that smells really good, and they're used in flavorings. Okay, like these few and where they're located, like anisaldehyde, vanillin, cinnamon aldehyde, citral, and camphor. You can see that those are in different flavorings. Okay, if you a lot of times for foods or different food, if you have a very pleasant odor, many times that is because of the aldehyde and the ketone. Okay. Especially the one in cinnamon. Okay, the strong odor in cinnamon is because of the aldehyde, called cinnamon aldehyde. Okay, so right, and finally, these are 3 structures. You can see they're all similar. Okay, similar with the 4 rings. They're called steroids, and in particular, these steroids are called steroid sex hormones. Okay, we're going to study them in chapter 8. You can see they're all ketones. Okay, ketones: testosterone, progesterone, and cortisol. They're different purpose of hormones. Okay, those first 2 are sex hormones. Cortisol is not. Okay, cortisol. They're all hormones. Okay, but they're ketones as well. Okay, we'll study them more in a systematic way in chapter 8 when we study lipids, because they're also stereolipids. And lastly, is something you guys, if you girls interested, you can read. A lot of perfumes are made by aldehydes, a mixture of aldehydes, because those small chain aldehydes ranging, you can see that from ranging carbon number 7 to number 13 or 14, each one has a unique pleasant odor, okay, pleasant odor. So perfume industry, sometimes they use a combination or different combination of different chain length of aldehydes to make the perfume. Okay, of course, you won't know the ingredients, you won't know the ratio, you never know. But they're basically aldehyde perfumes. Okay, including, again, you guys can read more if you're interested, including Chanel number 5 is an aldehyde perfume. Okay, so those are some quick view about these aldehyde and ketones to show you they're around you guys. We're seeing them, we're using them every day. Okay, and with or when, no matter you realize that, but we're using them. All right, so next, okay, more importantly is let's take a look the physical properties of aldehyde and ketones. Okay, physical and aldehyde and ketones. Now, first, when we study physical properties of aldehyde ketones, we study those compounds as a group. So that means we do not discriminate or distinguish between aldehyde versus ketone. When we study physical properties, they are the same type of compound because they both have what? The carbonyl group, the CO double bond. Okay, so we call this physical property the physical property of what? Aldehyde and ketone. Okay, now because of this CO double bond, okay, because of the CO double bond, which is a moderate polar group. Okay, moderately polar group. Here I want to explain what is moderate polar means. Okay, remember we studied in chapter 1 through 3 now. We said chapter 1 and 2, the hydrocarbons are what? Non-polar, right? Means what? Not polar at all. And what do we see them? Because they're not polar, what do we see about their boiling point?
Low.
Very low, is that right? Because their interaction is what? Is weak. And on the contrary, we study chapter 3 because of the OH, which is very polar. What do we see about alcohol? The boiling point is what? Very high. Why? Because the polar group makes them interaction what? Strong. So here we use the word moderately polar means what? Because of the carbonyl group, the polarity of aldehyde and ketones is what? Is between what? Hydrocarbons and what? Alcohols. Okay, so this is a polar group, but not as polar as what? As OH. Okay, OH. And this picture shows you what polar means again. Take a look. This picture shows you 2 carbonyl groups. Okay, polar means oxygen has a little what? Negative charge. The carbon has a little positive charge. So if you have 2 molecules, they can interact like this. The carbon interact with what? With the O. The O interact with what? With the carbon. So makes these molecules what? Interact with each other. But because the group is not very polar, moderately polar, so this interaction is not as strong as what? As OH, as hydrogen bonding. Does it make sense, guys? Because of the word moderately polar. Okay. The interaction is here, but not as strong as what? Hydrogen bonding. If you remember that interaction in chapter 3, hydrogen bonding. Not as strong. So that, again, in turn, gives us this. Okay, this is a very useful chart showing you the comparison. Okay, this chart lists 4 molecules. Okay, with real numbers. The first molecule is what? Hydrocarbon. Is that right? This is the boiling point. Again, you don't need to memorize the number. We're just comparing. 0. The last molecule here is the what? Alcohol. Is that right? This is the what? Boiling point, close to 100, 97. And take a look at the middle two. This is an aldehyde, this is a ketone. Their boiling point is what? Between hydrocarbon and what? And alcohol. Why? Because the group is what? Not as polar as what? OH. But still it's polar. That means it's higher than hydrocarbon, which is not polar at all. It's non-polar. Does it make sense? Again, that's why I said the chart is very, very nice for you. I would never ask you what is the boiling point, but you can what? Compare. You know the range somewhere. Okay, somewhere. Okay, and this chart is also useful. Okay, now we have an extra line. If you guys remember the chart, you see that in chapter 3 as well. Okay, the bottom line is what? Is hydrocarbons and ethers. We know ethers are close to hydrocarbons. The top line is what? Alcohol. And the middle line, you can see that is what? Aldehyde. Okay, and you can see that this dashed line is room temperature. You can see the first aldehyde is what? Lower than room temperature. That's why we can formaldehyde as a gas. Formaldehyde is a gas. Alcohol, there's no gas because the alcohol, even the first alcohol, the boiling point is higher than room temperature. So methanol is a liquid. There's a reason for that. Make sense, guys? Boiling point. Okay, and like I said, when you study more, you can have more general idea. Especially you can compare across these different types of compounds. Okay, next, you know that we're going to study what? Water solubility, right? And because aldehyde and ketones, because the carbonyl group is moderately polar, and it's still polar, even moderately still polar. So they can interact with water through hydrogen bonding. Okay, they don't have hydrogen, but water has hydrogen. So you can see that their oxygen of either aldehyde or ketone can interact with what?
Hydrogen.
With the hydrogen and water. Okay, so aldehyde and ketones are water soluble. Okay, water soluble. But not as soluble as alcohols. Okay, alcohols. But the same as we studied in chapter 3. Aldehyde and ketones are soluble has a condition, has a very important condition. That is what?
Chain of carbon.
The chain cannot be what?
Long.
Cannot be too big. Okay, that's why I put here, you can see in red. A low molecular weight. What does it mean low molecular weight? Smaller ones. Okay, smaller ones. Why? Because as the chain gets bigger, this group will become what? Less and less dominant. Is that right? The chain will become more and more what? Dominant. And we know the chain is not water soluble. It doesn't like water. So, aldehyde and ketones are water soluble in general. Even though they're less soluble than alcohols. But they're generally water soluble. But there's a very important condition. That is, the molecular weight or the size of the molecule cannot be what? Too big, too high. Make sense? And here is a chart. Like I said, sometimes the data in the chart will speak louder than when you just purely describing it. Okay, on the left side of the table, take a look, are aldehydes. From target number 1 to target number 8. These are the water solubility. First two aldehydes, the water solubility is infinite. Means what? You can dissolve with water as much as you want. Starting from number 3, you can see the water solubility drop to 16. And then move down to 7 and drop further down to what? Close to 1 and 0. So we can say by number 7 aldehyde, heptanol, the water solubility is what? Close to 0. It's almost the same as what? Hydrocarbon. Right? It's only dissolved a tiny bit. On the right side of this table are ketones. Of course, the simplest ketone is 3 carbons. That's why you don't see those. Okay, the first ketone, acetone. the solubility is infinite. Move down to 4 carbon, drop to 26. 5, 6, 7, you can see drop to what? Further. Until to 7 to 8 carbons, you drop to what? 0. What does it tell you? When the molecule gets bigger and bigger, the size of the molecule becomes more and more like what? Hydrocarbons. Less and less like what? Aldehyde or ketones. Does it make sense, guys? Okay, those are all we need to know about the physical properties. Okay, again, guys, I want you to make a summary. Okay, first, what about boiling point? The boiling point, because the functional group is what? Moderately polar. Moderate polar means what? We want to compare with hydrocarbons and what? Alcohols. Moderate means they're between. And because of that, the boiling point of aldehyde and ketone is what? It's between hydrocarbons and alcohols. Okay, and solubility is also between hydrocarbons and what? Alcohols. And we do have the same trend as we studied in chapter 3 is the solubility will decrease as what? As the chain length or the size of the molecule what? Increases. See, if you make that summary, you will answer lots of questions. Okay, lots of questions. And that means in your test, in the first test, you're not going to compare, not only going to compare molecules of the same type, you're going to compare molecules of what? Different types. Okay, regarding water solubility and what? And boiling points. Okay, so that's physical properties. Do you guys have any questions? Anything you want to clarify, repeat? Good? All right, let's take a look. Reactions. Okay, reactions. In this chapter, we're going to study 3 big types of reactions. Okay, 3. Only the first reaction here. Only the first reaction here distinguishes aldehyde and ketone. That means only the first reaction you see different results with aldehyde or ketone. The second and third reactions, types of reactions, are no difference, okay, between aldehyde and ketones. Okay, you will notice that as well, but I want to point out the first reaction. So the first reaction is oxidation. Okay, oxidation. Okay, we know oxidation. We studied in chapter 3. What is oxidation? Is decreasing CH bond and what? Increasing CO bond. Is that right, guys? Okay, take a look. What happened? This is an aldehyde. And we know the symbol means what? Oxidation, right? Take a look what happened. Between here and here, what do we get?
Carboxylic acid.
You're adding a what? O between the C and what? H. Do you guys see that? CH becomes what? COH. You guys see that? You basically add a what? Add a CO bond here. Of course, the O bond with hydrogen as well. Okay, again, this is the result. The reaction doesn't happen this way, but for you, you don't have to know how it happened. All you need to know is, what do we get? What happened? What's the difference between the product versus the starting material? Aldehyde, CH bond. Remember, aldehyde has a what? CH, right? Has a hydrogen. That makes an aldehyde. And the hydrogen and the C got inserted by what? O. Is that right, guys? Okay, that's what, again, that's how I explain to you guys. You can understand in the way you want, you feel comfortable. But what happened is basically hydrogen is what? Inserted between what? C and H. And you get a new functional group, COOH. We call that a carboxyl group. And the molecule is called a carboxylic acid. We studied this in chapter 5, whole chapter 5. That's aldehyde oxidation. Ketone, because the ketone carbon has no hydrogen at all, it will not be oxidized. If I give you a ketone, you put an oxidation, you can put no reaction. Like I said, this reaction what is the one distinguish what? Aldehyde and ketone. And because of this reaction, aldehyde and ketone are different types of compounds. Okay, one will be oxidized, another one will not be oxidized. Good, everyone? You know how to do this reaction, right? What? Put a what? Oh, everything else you don't change. You just what? Copy, 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 right? Okay, give you 2 minutes. Tell me what you get for these two reactions. Very good. Beautiful. Again, whenever you're done, you can show me the very good. Beautiful. Good. Yeah. What was the second one?
Oh, the second one I did.
Yeah. You done both? Perfect, guys. I see you can do now. Hopefully you can all get it right in the test and quizzes. Okay, that's makes me happy. Okay. What was second? Oh, over there. Perfect. Make sure that the bond double. Don't lose things.
Oh,
CO double. CO double bond.
But is this one supposed to be
The
double?
same, yes. Don't drop. If you show me this, you got 0 in the test. Okay, the double bond not change. You're only what? Adding in O. Or
Okay.
change the H to an OH,
Okay.
whatever you prefer. Good, guys. Like I said, I hope you can. Okay, the first product is OH. Okay, again, the best is to show the C now bond with what? Bond with the O. Okay, and O of course bond with the H. Okay, and the second product is OH. The same, you bond this O with what? Yes. Both are carboxylic acids. Okay, both are carboxylic acids. Alright, so very good, beautiful guys. Before I move on to two reactions, I want to introduce you two commercial reagents. Okay, commercial reagents that are used to carry out this reaction, the oxidation reaction. Okay, the commercial reagents are used to carry out the oxidation, basically are used to what? To distinguish aldehyde and what? And ketone. And both reagents will give us a positive reading or positive results to show, hey, this is reaction is happening. If the reaction is happening, that means what? It is an aldehyde. Okay, just like you're doing a COVID test, right? It give you a negative test and a positive test. The commercial reagent will give the same, positive test and a negative test. So I will show you what they are. The first reagent is called Tollens reagent. Okay, Tollens reagent. It's based on silver plus ion. Okay, silver plus ion. So in this case, if we're using Tollens reagent, that little bracket O, you guys remember that O is silver. Okay, we never specify what the O is. Okay, but if we're using toluenes, that's the O. Is this guy who oxidized the carboxylic acid, oxidized the aldehyde into what? Into carboxylic acid. If that's the case, if you treat an aldehyde with toluenes reagent, the silver plus will be reduced back to silver. That will be deposited on the very beautiful inside wall of the container, whatever container you use, test tube flask. And you will see very shiny mirror of silver like that. We also call this silver mirror test. If you guys in a chemistry club, every year in Christmas, now it's spring. In Christmas, we'll make Christmas ornaments using this reaction. Okay, put it inside the the ornaments, the ball. You put the reaction, and the silver is deposited in the shiny. You get shiny ornaments. Okay, that's the first reagent. And the second reagent you guys gonna use in your lab. Okay, not today, the aldehyde lab. It's called the Benedict's reagent. Okay, in Benedict's reagent, that little O bracket, instead of silver, is copper. Okay, it's copper. Copper 2 plus. Copper 2 plus is blue, very beautiful sky blue color. Okay, you will see that too. Again, you guys will use this. Okay, this is what Benedict's look like. Beautiful sky blue because of the copper. And again, if you're treating that with an aldehyde, reaction is the same. Aldehyde becomes what? Carboxylic acid. But the copper will be reduced to copper oxide. And to be more accurate, copper 1 oxide. And this copper oxide is a solid with reddish brick, dark red color, like a brick color. And when you see that, you know you're treating what? An aldehyde. Okay, an aldehyde. So these 3 test tubes, you can see that glucose, which is an aldehyde, we studied in chapter 7, gives a positive result. Okay, the other don't, because it still remains the same color as the Benedict's reagent. Good, everyone? You need to know the names of these 2 reagents. Okay, toluenes and the Benedict's. What they're used for? They're used what? For oxidizing aldehyde. Okay, especially Benedict's, you will use them in the lab. Okay, you will use them. All right, next. The second reaction. Okay, the second reaction. Like I said, only the first reaction distinguish what? Aldehyde and ketone. The second and third reactions, they don't. If you take a look at the second reaction, you will see what I mean. Okay, this is, again, the name of the group called CO double bond is called
Carbonyl.
carbonyl group. If I treat carbonyl group with hydrogen, okay, with hydrogen, what happened? Can you use your word? Tell me what happened. The CO double bond becomes single bond, and then what? Each one of these 2 atoms are added by a what? A hydrogen. Right? Do you guys recall seeing something similar like this before? When we study what? Alkenes, is that right? Alkene, the CC double bond. If we treat with hydrogen with catalyst, we can what? Do very same thing, right? CC double bond becomes what? CC single bond. Then we add what? Hydrogen. They're both the same type of reaction. We call them hydrogenation. Okay, hydrogenation. And because of the fact, guys, hydrogenation is based on what? We use hydrogen. But because of the fact, take a look. After we had hydrogen, we added what? CH bond. Is that right? We call this process reduction, which is the opposite of oxidation. Okay, what is oxidation? remove CH, then you add CH is called reduction. Okay, reduction. Okay, reduction. Here, let me put the words on here. Okay, this reaction is called reduction. Okay, from reduce, reduction. Okay, which is again the opposite of what? Oxidation. Okay, the opposite of oxidation. Okay, because we add what? Hydrogen. Good? You guys understand the reaction? Okay, let's take a look at these two reactions. The first one, CO double bond. With a hydrogen on it, we know this is a what? Aldehyde. Is that right? When we have an aldehyde, when you treat it with hydrogen, again, CO becomes what? Single bond becomes, the double bond becomes what? Single bond. You add a hydrogen to the O and add a hydrogen to what? To the C. After you add a hydrogen to the O, what do we have? OH. And compound with an OH is called a hydroxy group, but the molecule is called a alcohol. Is that right? You guys see this is an alcohol? Now, keep moving. Still the same molecule. You know what's going on. We know this one has had hydrogen before. Is that right? After the reaction, you add what? Another hydrogen. So an alcohol with two hydrogen on the C, we call the hydrogen alcohol a. Let's remember. Primary alcohol. Or let's do another way. This carbon has how many groups? One group. Because another one is what? Hydrogen. So after you add hydrogen, this carbon has how many groups? One, still one group. There's only you and only a hydrogen. Is that right? A alcohol with a carbon attached to only one group is called what? Primary alcohol. So, top reaction. Hydrogenation or reduction of a aldehyde gives you what? Primary alcohol. Okay, primary alcohol. Why primary? Because the carbon has what? One group attached to it. Or you can say the carbon now has two hydrogen. Either way, you understand the definition of primary alcohol. Does it make sense, guys? The bottom reaction, take a look. You can study them together. This guy, the carbonyl group, has what? Two carbons. So this is a. No, this is a what? This molecule is what? Is a ketone. Is that right? And after you treat with hydrogen, CO double bond becomes single bond. You add a hydrogen here, you add a hydrogen what? On the O. Right? This is also an what? Alcohol. Now because you have two groups here, that means this carbon have what? Has two groups. And we call this alcohol a secondary alcohol. See, that reaction is the same. But because you started with aldehyde or ketone, you get different types of alcohols. Aldehyde gives you what? Primary alcohol. Ketone gives you a secondary alcohol. But the reaction is the same. Okay, when you do the reaction, what would you do? Copy, right? Then break this double to a what? Single. Then what? Add hydrogen to the O, add hydrogen to the C. Okay, now, I don't know if you guys noticed that already. In chapter 3, in this chapter we just studied is the CO double bond can be converted to a single bond by adding what? Two hydrogens. Is that right? But if you remember, both in chapter 3 and also in the beginning of this lecture, and the first page of this lecture, we know an alcohol can be oxidized into what? An aldehyde or ketone. Is that right? What do? Take the hydrogens away and then what? Make the double bond. You can see that these these two are reverse process. If you remove the hydrogen, make a double bond, we call what? Oxidation. If you take away the double bond, add hydrogen, we call that what? Reduction. A reverse process. Okay, of course, in this case, aldehyde primary alcohol. Primary alcohol what? Aldehyde. And then I'm gonna put what if secondary. Okay, the same process. Let's draw a secondary alcohol. Okay, this is a what? Ketone, right? If I add hydrogen, what do? Change this double bond to a what? To a single bond, then add hydrogen here and what? Added hydrogen here. We call this process what? Reduction. Okay, reduction. And then if I remove the two hydrogens, put the double bond back, we call the process what? Oxidation. Okay, of course, in this case, you're taking the hydrogen away, minus a hydrogen. Okay, minus hydrogen. Use a different color. Hydrogen, hydrogen. Okay, like this. Is that the same, guys? The only difference is what? Secondary alcohol, ketone. Primary alcohol, what? Aldehyde. They're a reverse process. Does it make sense? Okay? We'll probably practice more next week. Okay? Last reaction. Okay, last reaction. I will be very slow on this reaction because this is probably the most difficult reaction in the whole first 6 chapters. Okay, I'll be slow. I'll show you how do we. I'll put the arrows here as already, but I will show you on board as well. Okay, the third reaction is adding alcohols to an aldehyde or a ketone. Okay, adding alcohols to an aldehyde or a ketone. So, let's first draw the structure of an aldehyde. RCOH. This is an aldehyde. Is that right? And we said this guy is adding what? An alcohol. What is an alcohol? ROH. Is that right? I can put the prime here and show this R may be different. Okay, maybe the same, I don't care. I only care what type of compound. So, in this reaction, if I want to add an alcohol to an aldehyde or ketone, what is the functional group of an aldehyde? The carbonyl group. Is that right? So if I want to add something to the carbonyl group, what do you think happened first?
The bond will break.
The double bond has to be changed to a what? Single bond. So the same. So let's copy the structure first. Okay, now I just want to show you how do we add alcohol to it. In order to add this alcohol, again, I need to change the double bond to a what? Single bond. Now I want to add this guy, alcohol. That's the most tricky part. I mean, not tricky part, most difficult part to remember. When you add an alcohol to the CO double bond, the hydrogen of the alcohol, okay, let me use a different color, is added to the O. The O of the alcohol is added to the C. Remember, you're break the O of OH. The hydrogen of the alcohol is added to the O. The O of the alcohol is added to the C.
So what is R dash? Like
Here.
no, No, in the,
This one?
yes.
The same as this R prime. This is
Oh, okay.
showing just an R. The reason I put a prime here because this one has an R too. It means they be the same. I put the arrow here in your lecture notes. The hydrogen is added where? To the O. The O is to the where? To the C. Do you guys see that? This carbon I'm pointing at is the carbonyl carbon. Now, of course, you don't see the double one. You only see what? Single bond. Okay, single bond. So after the first step, I added one alcohol. Okay, added one alcohol. From here, I can add another alcohol to the structure. If I want to add another alcohol, again, let me copy this on the right. H, the same. If I want to add another alcohol, I simply replace the OH. Does it still show on the screen, on the recording? That's the whole structure?
No.
Now we can move a little bit. There we go. If I want to add another alcohol, I replace this OH with the O again, with that O again, this here. So after this, you can see that two alcohols. You guys see that? This is the OR. Where's the OR come from? The alcohol. This is the OR. Where's the OR come from? The alcohol. So after these two steps, two alcohols are added to where? To this carbon. What is this carbon? That carbon. Do you guys see that? That's the carbon. Do you guys see that? So after two steps, we're adding two alcohols to the carbonyl carbon. Does it make sense? And the same shows here, whichever you feel. Now let's check the names. We know this is an aldehyde. Okay, aldehyde. After adding the first alcohol, the product here is called a hemiacetal. Okay, hemiacetal. Hemi, I mean the half. Acetal, A-C-E-T-A-L. Okay, acetal. And the final product is called acetal. No hemi. So aldehyde gives acetal. The difference between these two is hemiacetal, there's only one alcohol added. Acetal, there's what? Two alcohol added. How can we tell the difference? Acetal has no OH on this carbon. You can see that both O is what? OR. They're from alcohol. Hemiacetal has a what? Has an OH. Okay, let me go over this again on board. And again, it's over there as well. Aldehyde. Alcohol. Good? The R means a group. Again, these two R's can be the same or different. I put prime here to show you this R is from the alcohol. This R is the aldehyde. That's the only difference, the only purpose. First step is what? Break the CO double bond. If you want to add something, you need to change double bond to what? To a single bond. The H of the alcohol is added to the O. The O of the alcohol is added to what? to the C. Of course, the O is bonded to the R. You have to add OR together. But what added to the C is the O, is the oxygen of the alcohol. Make sense? The product has one alcohol added with an OH on this carbon. It's called hemiacetone. Yes.
So the OH, the O was already there. So the hydrogen came from the alcohol and it bonded to the.
Correct. This O is that.
And then
yes.
the OR is from the alcohol, the whole thing.
This OR is from the alcohol.
The whole thing, yeah.
Yes. And then you can add another alcohol by replacing this OH with what? With another OR. Again, we're counting 2 alcohols. Where are they? They're here. You see that? Let me put it. Do I have a different color? Green. Okay. OR. OR. See that? Finally, they're here. See that? They're added to the what?
C.
The C. What is the C? The carbonyl group. Make sense? Okay, if not, like I said, I'll be slow. Let's try it again using a ketone. Okay, using a ketone. R, C, O, R. Is this a ketone? 2 R groups on the C. Is that right? Okay, let's try the same thing. I'll use different color. Okay, alcohol, O, H. There's different color. So you guys tell me. After I copy, tell me. If I want an alcohol, what do we do?
So C bond will become single bond.
Change the CO double bond to a single bond. Good. And then
OH.
what is add to what?
The
The
hydrogen.
H adds to the
Oxygen.
O. Perfect. The O with the R together adds to what?
Carbon.
To the C. Okay. O with R together adds to the C. O R. Is that right? It's the same, right? That's the first alcohol done. Perfect. Next, I can add another alcohol. R O H. By what? Copy first. O. Too many colors. O R. By what? By changing the OH with another what? OR. You see that? They're basically what?
Similar.
The same. Okay, the same. Okay, the same. Let's name those guys. Okay. Not name, just tell you what they are. Okay, this is a ketone. Okay, the product here is called a ketone. Ketal. Okay, it's called a ketone. So what do you think this guy called? What do you think this is called? A hemiketone. Okay. Hemiketone. What's the difference between hemiketone and ketone?
Intermediate product.
There's an OH
No,
in the hem. That means what? You only added 1 alcohol. You can add another. Hemi means what? Half.
But the reaction will stop at 2 alcohols.
Correct. Now, a few things. Okay, a few things. Can cover everything. Okay, a few things. These 4 structures, okay, are very similar. So how do we recognize them? Okay, these 4 structures, here, the products, right? This is the initial products, these are the what? The final products. So how do we recognize them? Let me zoom a little more so you guys can see better. Okay, how do we recognize them? First, These 4 structures all have one thing that is in common, and also not common in organic chemistry. So you won't see structures like this aside from these 4. That is a carbon single bonded with 2 oxygen. You can see that? All 4 of them with a carbon what? Single bonded with what? 2 oxygens. Again, this is a very unique structure. You won't see anywhere else. That's how you see, oh, I see a carbon single bonded with 2 oxygen. Then that means what? They're either acetals or ketones. Does it make sense? That's how we recognize them. Number 2. After you identify the carbon with 2 oxygen single bonded, how do we know if the structure is from an aldehyde or from a ketone?
There's a hydrogen in the aldehyde and
Based on the hydrogen. Is that right, guys? If on the carbon there is a hydrogen, that means what?
aldehyde.
This is from what? An aldehyde. If on the carbon there's no hydrogen, do you see that? That means it's from what? A ketone. So you can tell whether you're looking at an acetal or what? Or a ketone. Is that right? By what? By look for the hydrogen. Remember, the reaction doesn't change anything else. We are only what? Adding stuff on the C. So the hydrogen, once there, will still be here. Make sense, guys? And finally, how do we know if I use the prefix hemi?
It's only one OH.
OH. Is that right? If you see the OH means what?
Hemi.
You need to put what?
Hemi.
Hemi. Good? Okay, that's why I put them both together to give you a summary. Okay, the reaction are the same. Okay, reaction are the same. Okay, this is on ketone. Again, I put the arrows so you can take the notes. Ketone, ketone from a ketone. Here are the 4 structures. Take a look. All 4 again has a carbon with what? 2 hydrogens what? Single bond. You guys see that? Again, I said this structure is not common in organic chemistry. You won't see other structures like this. Okay, you can identify them. Next, if you see that carbon with 2 oxygens single bonded has a hydrogen, then we know these are from what? Aldehyde. So they're what? Acetals. If one of the oxygen is OH, then you add what? Hemi. Good? I know it's complicated. That's why we're very slow. On this right side, okay, on this right side, 2 are single bonded, 2 oxygen single bonded, but the C has no hydrogen. We know they're what? Ketones, because they're from what? Ketone. And the one with an OH is with a prefix Hemi. Does it make sense? Okay, we'll keep on this reaction and review this reaction one more time next Monday. Okay, then we'll start chapter 5 on next Monday as well. Again, like I said, this reaction involves too many molecules and too complex structures. I want to be slow. And hope you guys can get a full understanding on this. Right? I'll draw this again on Monday. Can you close the recording? Okay, and we're done.